Hey guys, this is Malinki. Welcome back to my channel, Voice of Malinki. Today we'll talk about induced feed model. And if you are new in my channel, please subscribe my channel. And if you like my video, please do like, comment and share my video. So basically induced feed model is a model, it is a potential model for how substrate may bind to the active site of an enzyme. This model was proposed by Daniel Koshland in 1958. According to this hypothesis, an enzyme's active site is not ideal for substrate binding when it is in the unbound state. Thus, the name induced feed model is termed so for the induced small change of the active site of an enzyme such that substrate can feed properly. So what does that mean? According to this proposal, the active site of enzyme is not ideal for its substrate when the substrate is free, or you can say when the substrate is not attached to the enzyme. So how does the substrate fit in the enzyme? The answer is there is a forced change in the active site so that the substrate can fit in the enzyme properly. Hence, the name is induced feed model. Let's see the mechanism. So the substrate arrives at the active site of an enzyme where it doesn't fit properly. In this image you can see this is the substrate and this is the enzyme and this part is the active site. So the shape of the active site and the substrate is not exact similar. No, these and this part are little bit different. Okay, so substrate molecule is bound to the active site via electrostatic interactions, hydrogen bonds and hydrophobic interactions. So once a substrate binds the active site, there are many types of interactions such as electrostatic, hydrogen, hydrophobic interactions, many types of interactions are there. Now the active site changes its conformation until the substrate makes a tight bond with it, forming the enzyme substrate complex. In order to achieve this, the amino acids that make up the active site are aligned into appropriate position. So, at first there is a loose interaction between substrate and the enzyme. Okay. Later, the amino acids of the active site of the enzyme are aligned in a way that provides a tight interaction between enzyme and substrate. So the conformational change is there, you can see. The active site was just like this before, and now after the attachment of substrate in the active site, there is the conformation change and now it is like that, and here is the tight interaction between substrate and enzyme. And once it is done, then the product will be formed just like this, and then the product will be released from the enzyme and the enzyme is now free and the active site is just like this. You can see the enzyme active site is again just like this and the enzyme is now free. This is ready for next round. So this is all about today's lecture. I hope you liked the lecture. Thank you for watching my video.